look at this question on the board, we have the limiting function of x sine x all over x squared plus 1. We want to find the value as x tends to infinity. If you look at this question, you can approach it in a very different way. There are different ways with which you can solve this. Number one, you can use Hospital's rule to solve this. But I don't want to use that. I want to use a squeeze theorem. According to squeeze or sandwich theorem, we are going to look at this function. Remember, squeeze theorem talks about when we have a different function. If I have function of x less than or equal to g of x, also less than or equal to h of x. Now, according to the sandwich theorem or squeeze theorem, it makes us understand that if I take the limit of this now, the limit function as x tends to infinity of this particular f of x, then is equal to this very one, the limit as then this could be k. Let's call here k. It's not just infinity. This is k. K represents any value. All right. As s also tends to k. All right. Then of h of x. So it's the same thing. What this law says that what if this one is equal to this one, then the limit of the middle is also equal to. So this limit must also be equal to. So judging with that, we will come and solve this now. For us to have this, remember, for us to have this now, for sine has to be greater than minus 1, greater than minus 1, greater than or equal to minus 1, that is what sine function, sine x, but less than or equal to 1. Alright, so for me now to use sandwich theorem to solve this, I will have to look for a way to have a value here and have a value here. What can we use to multiply this particular one to have our sine x? It means that what this particular function that you are seeing here, what you are having here, it means x all over x squared plus 1 times sine x. This is what this value, this is what will give you. Using this one to multiply this is what will give you this. So remember, our range has to fall within this. So in that case, we have to put this one in the middle here, and this particular one we'll put it on the left side. Then while this one will be what on the right side. So that's how we are going to what solve it. So now we are going to solve using a squeeze theorem. So you bring this now, put it here, multiply here, then use this one to multiply here, which means we are going to have a minus, this is a minus x all over x squared plus 1, then less than or equal to x sine x. Remember, it's this one that multiplies this that gives you sine. Then x sine x all over x squared plus 1. Then here we also bring this one to the right side. Then it will give us less than or equal to. Here will give us less than or equal to x over x squared plus 1. So at this point now, find the limit of this. If the limit of this one is equal to the limit of this, it means this also has the same limit. So let us find the limit now. If I take the limit as x now tends to infinity of x, that is minus x over x squared plus 1. Let's find this now, then we also find this. So at this point now, if you wish, you can use a Hospital's rule, but I don't want to use Hospital's rule. Let me carry out simplification. Let me deal with this particular x squared here from the denominator. I want to reduce this one. What I will do, I will say this will now give me for the limit that is minus, or you can put minus limit or whatever, become x over x squared. Then this is what x tends to infinity. Then all over x squared over x squared. Then plus 1 over x squared. So at the end of the day, the numerator is going to give me, that will now give me a limit. Okay, let's put minus at the back here because it's negative here. Here we're going to have one of the s is out, remain one of the s down. We have x over, okay, 1 over s rather. This one is gone, remain one of the x here. We have 1 over x all over, here becomes 1 plus 1 over x squared. Remember, this is what x tends to what? Infinity. So at this point now, plug in this infinity. Remember, when you are having something 1 all over infinity, automatically becomes 0. So taking limit of this 1 over x tends to infinity, up here will give me 0. Y here is giving me 1 plus what? Also, we also have here this s squared. Then squaring infinity is this thing as infinity. So here we also give me what? 0. So at the end of the day, the limit here is what? 0. That's for this particular left side. Remember, there is a negative here, whether minus 0 or whatever. So it's 0. So we have a negative there. So as long as everything gives us 0, it's 0. Now let's go to the right side. If I also take the limit of this, of course, the opposite of this is this. So you see the same thing. Then if I take the limit, x tends to infinity of x all over x squared plus 1. The same thing, you also apply it to become here. If I divide both the numerator and the denominator by x squared, I'm going to see how the limit as that is 1 all over x now. Then all over 1 plus what? 1 over what? S squared. Then this is what x tends to what? Infinity. So at the end of the day, we are still going to have a 0 all over what? 1 plus what? 0. So if this one is equal to 0, and the first limit we got on the left side is also equal to 0. So we therefore conclude by squeeze theorem that the limit of this particular question or this particular function is also equal to 0. So that's the answer. So the limit of this question now, the solution to this question is what? 0. So that is the answer to this question. If you find this class very interesting, please do not hesitate to share this video. Bye.